Am I audible and screen is visible?
Yeah, sir.
So we are doing carbonyl group. What
Yes.
do you mean by carbonyl group?
So the organic compounds which contain the carbonyl functional group, that is C double bond O, are called carbonyl
And
compounds,
what are the example?
like aldehydes and ketones.
Aldehyde. What else?
Ketones,
Ketone. Because in
carbo.
aldehyde
Yeah.
you have hydrogen.
Yes.
Here, correct. What else? Carboxylic acid.
Carboxylic acid. Yes, sir.
So in carboxylic acid, here you will have OH
OH.
because carbonyl is a common thing, right? What else?
Uh, acid.
Acid halide,
Halide. Yes, sir.
acid amide,
Amide also. Yeah.
anything else?
Mm,
You have ester as well.
ester.
Even in
Yes.
ester, you have acid anhydride as well.
Acid anhydride. Yes, sir. Yes, sir. Remember.
C double bond O, O, C double bond O, R, R, R is common everywhere. Got it? So,
Yes, sir.
when we say carbonyl, in all these aldehyde, ketone, carboxylic acid, halide, amide, acid halide, acid amide, ester, acid anhydride, all have carbonyl group. But here we are focusing on more aldehyde ketone. But in general, you will understand the property of everything. Well, example, when we take any carbonyl group, remember this is not only for aldehyde ketone. Any carbonyl group have basic properties same. So if you see this carbonyl group, what is the hybridization of carbon in this
So sp2.
sp2? Why? Because double bond,
Double bond. Yes.
correct? What should be the bond angle in this case?
In sp2 bond angle is oh, so bond angle is
Whenever
120.
there is a
120.
120. If you have sp hybridization, then
In case of sp hybridization, then it's 180.
180. Ravi, Ravi, am I audible? Chinmay,
Yeah, sir.
Samarth, Samarth came. Samarth, am I audible?
Yes, sir, you're audible.
Okay. So we are doing carbonyl group, aldehyde, ketone, carboxylic acid. In next three class, we'll complete aldehyde and ketone completely. Okay. Carbonyl group, you know, aldehyde, ketone, carboxylic acid, acid halide, acid amide, ester, and acid anhydride all have this common carbonyl group, right? What should be the hybridization of the carbon in carbonyl group,
Uh,
Samarth?
Single double bond sp2.
sp2. So what should be the bond angle?
180 degrees. So 120 degrees.
120. In sp, it will be 180.
180.
Cinema in sp3, what will be the bone angle?
Sir, 109.5.
Very good. 28 minutes. Samarth, if it is sp3d,
Sir, 90 degrees and 120 degrees.
120. Yes. Okay, so this kind of question is asked. So here in carbonyl group, we have this sp2 hybridized carbon, 120 degree angle. Is pi bond. Uh, Chinmay, is this carbonyl carbon polarized or non-polarized?
Sir, it is polarized, sir.
Polarized means
Sir, this thing, sir, it's polarized meaning oxygen is partially electronegative and it will acquire negative charge, and carbon has partial positive charge. So they're
why?
sir,
Why?
because
Because
how to explain? I'm not able to explain.
Samarth,
Sir, electronegativity of oxygen.
electronegativity difference. Oxygen is more electronegative, attract more electron and try to get more negative charge compared to carbon. So Samarth, in this carbon is electrophile or nucleophile?
Electrophiles.
Electrophile. Because it have positive charge, so it will try to attract electron toward it. And oxygen will be Chinmay, electrophile or
Nucle
nucleophile?
nucleophile.
Nucleophile, nucleus loving because it itself contains the negative charge.
Negative.
So nucleophile is a Lewis acid or Lewis base, Samarth?
Uh, Nucleophile is Lewis base, sir.
Lewis base. And Chinmay electrophile will be Lewis
Acid, sir. Acid.
acid. How do we know? Electrophile, electron loving, it means they have shortage of electron. Electron deficient is acid. Excess electron means base. So, uh, Chinmay,
Yeah.
can we have dipole moment in this situation?
Like
Hmm.
how do you tell? They are substantial dipole moment.
Yes, they have substantial dipole moment. Why? Because there's electronegativity difference and electron will move in particular direction like
Yeah.
this. Correct? Samarth, if you compare carbonyl with ether, which one will be more, which one will have more dipole moment?
Sir, carbonyl.
Why?
Sir, ether will have net dipole moment 0, like if it's symmetrical.
No, in ether dipole moment is not zero because they are not present at 180 degree angle. It look like they are present at 180 degree angle, but when you diagram, there are lone pair according to chemical bonding. You always get question from chemical bonding. Okay, there are
Hmm.
two lone pair of electron on the oxygen, and because of that, bond angle is not 180 degree, but definitely it is less than the carbonyl. Got it?
Okay.
So is
Remember,
it
it
because
is
of
not.
polarity?
Polarity will be more in the carbonyl group because there is only one direction. But in this case, what will happen if you see here polarity, then there will be direction. And polarity of carbonyl is more than the ether. And this question, trust me, can be asked, and you will feel logically, you will feel key. Ether have more dipole moment. Samarth, why you will feel that?
Sir, the two arrows, I think.
Exactly in these two arrow, direction is toward the oxygen. In lone pair, direction will be away from the oxygen. All are moving in same direction, and you will feel, oh my God. In this case, dipole moment in ether is more logically, and it took like this. Cinema got it?
Yeah, sir. Understood.
Though it is written in NCERT, but because it is written in NCERT, only then we can answer. Otherwise, exact based on the number, it's difficult to tell. When it comes to the preparation of aldehyde ketone, it's quite easy because most of the thing we did already in the previous chapter. So we are not doing anything new, but you have hydrocarbon parts in there here, Samarth. We did hydrocarbon now already.
Hmm.
That part will come into the picture. So first, Chinmay, if you take alcohol, primary alcohol, what will be the product?
Aldehydes.
Very good. What should be the reagent?
Forgot.
What should be the reagent? Like if you have alcohol and you want to make it aldehyde, is this oxidation or reduction?
Sir, it's reduction, sir. So LiAl
It is
H4 or
oxidation.
NaBH4.
It is oxidation because
Oh,
removal of hydrogen.
oh yeah,
Oxidation.
yeah, 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 yeah.
It is mild oxidation. And
Yeah, sir.
Samarth,
Yeah.
which
Hmm.
mild oxidizing agent we use in the last chapter?
Sir, PDC and PCC.
Pyridinium chlorochromate.
Pyridinium dichromate.
Correct.
Yes.
PCC. Got it, Chinmay? Do you remember?
Yeah, yeah, sir. I remember.
Okay. And if you have this Samarth, what will be the product? Same example you have PCC.
Sir, ketone.
Ketone. So that is the
Pro-
first method.
Propanol. Yes.
The first method is oxidation. If you do oxidation of alcohol, then you will form this product. Done. Because you know this, we will not take time. Second, dehydrogenation of alcohol. What should be the reagent, Chinmay?
Sir, in
Dehydrogenation of alcohol. How you
uh,
do this? Method is exactly same. You have alcohol, you will make aldehyde or ketone. Correct? If you take primary alcohol, same way, you will form aldehyde. If you take secondary alcohol, you will make ketone. My question is, what will be the reagent in this situation?
sir, can you repeat, sir? Your voice was breaking.
My question is, when you do dehydrogenation of alcohol,
Yeah,
so
sir.
alcohol is forming aldehyde ketone in the same way how we did in the previous topic, oxidation of alcohol. How it is different from the oxidation of alcohol? Second reaction. Samarth, what special you are doing in this case? First, you take alcohol in the vapor form.
Hmm.
Second thing, you use copper in this and you keep high temperature. Do you remember from the previous chapters? Same
Yes.
reaction.
Yes, sir.
Alcohol vapor form and pass through the heavy metal like copper, or you can take Ag also. Previous chapter it is written only copper. Here copper and Ag both are applicable and exactly in the same way. Any doubt, guys?
No, sir.
Samarth, ozonolysis, what will you do?
Sir, add ozone either with zinc
Hmm.
or without zinc.
What is the reactant?
Sir, any carbon with unsaturation, any carbon compound with unsaturation.
Yes. Any carbon compound with unsaturation means double bond or triple bond.
Double
Anyway,
bond.
this is given in 11th class hydrocarbon chapter. Okay. So when we do ozonolysis of alkene, here we take alkene. First you add ozone. So when you add ozone, instead of double bond, you will have ozone in between. Okay, instead of double bond, you will have ozone in between. This ozone will be added. Then ozone will break down. And in this case, if you take zinc, what will happen? Zinc oxide will come out and product will be one oxygen will be added to left side carbon, one oxygen will be added to the right side carbon. Chinmaya, any doubt?
No, sir. Understood. Ozonolysis.
And
Yeah.
ozonolysis, very popular in JEE. You will 100% get this question. Ozonolysis, and this is given in detail in 11th class. Alkene. Okay, so this is question for your objective part. Samarth, if you have CH2 double bond CH3 and you add zinc and ozone, what will be the product?
Uh, so methanol and ethanol, formaldehyde and ethanol.
Chinmay, how do we know that? The easiest way is you have two hydrogen here, you have this here. You break the double bond, add double bonded oxygen in each side, you will get product. As simple as that. Got it?
Okay. Yeah, sir. Understood.
The easiest way. Like you don't need to follow all these steps. Though these are the basic steps, but easiest way, simply add double bonded oxygen.
Yeah.
Now, Chinmay, you tell me what will be the product if I take CH3, CH, double bond, C, CH3, CH3, zinc, and ozone.
Uh,
If you add oxygen to this side, what will happen?
CH3 or C or CH. Yeah.
And other side,
CH3 C double bond O CH3. Yeah.
got it? Any doubt?
No, sir. Understood.
So here we get mixture of aldehyde and ketone depend what is the nature
React.
of the reactant.
Yeah.
Samarth, does this ozonolysis help in anything else?
Breaking cyclic chains.
Yes, it can break cyclic chain, help uh, in giving idea of position of
Original double.
bond, position of unsaturation. Ki where exactly you have double bond and triple bond will be explained by this. Okay, because if position is different, product will be different. And last is both these reactions are extremely important. Samarth, you already know this. And this is hydration of alkyne. Chinmay, do you know what is this reaction?
Yeah, sir. Like basic idea.
Okay, tell me, what is alkyne? CH triple bond CH.
Yeah, sir.
When
So,
when you do hydration,
yeah,
what will
in the
happen?
presence of dilute H2SO4, we'll get acetaldehyde.
Remember this thing. You use mercury sulfate. Remember this mercury sulfate is extremely important. Samarth, other than this, you also use mercury at one more place. Where? In this
Sir,
chapter, aldehyde ketone carboxylic acid.
sir, reduction, Wolf Kishner and Clemenson.
Clemenson reduction, right?
Yes, sir. Only Clemenson, sir, sorry, not Wolf.
Because in Wolff-Kishner we use
N2H4.
this hydrogen.
Yes.
So, Chinmay, if we do this simple breakdown of H2 into H positive and OH negative, right?
Yeah.
Same here, it is positive and negative. Hmm? So can we say it will be like this? CH2 double bond CHOH. Chinmay, do you think this is stable?
Uh, Not sure.
What will happen after that if this is not stable? Samarth.
Sir, it is enol, sorry, forms.
Yes, tautomerization, tautomerism.
Yes.
Okay, this is
Ketone.
enol form already. Double bond and all. Enol form is present here, and it will convert into keto form. You know, tautomerism means keto enol form. Tautomerism is keto convert into enol form. Got it? And if this is the situation, what will happen? It will convert into the keto form and no. Wait. One thing we have to do. Enol form is not possible in this case. So what we'll do, we will take CH3 here. Correct?
Sir, why is
Make
it not
sense?
possible?
Because for ketone you need minimum 2 carbon, 3 carbons.
Okay. Okay. Sir, but can it exist as aldehyde instead?
What?
One second, sir.
Yeah. Ask me your doubt.
Sir,
Okay.
why?
By the way, this is a very good point. I wrote like this, but if I write like this, what is the difference between these two? Samarth, which one is better? One or two?
Um,
This is two. This is two. This is one. Which one is better? Sinmay, both of you tell me. Sinmay, what is your answer? One or two? Which one is more stable?
I'm not sure, sir.
Okay. Samarth,
Sir, I think two, sir.
two is more stable because you know secondary carbocation is more stable compared to the primary. Here it will be primary carbocation. This will be secondary carbocation. And you know secondary carbocation is more stable. Got it?
Yes, sir. Okay.
Yeah.
Yeah. That is the reason you should know why this is happening. Because remember, all organic reaction you can read from NCERT. I'm using same NCERT content what you have in your NCERT. Correct? So what is the difference between you and me? Is I can give you logic why this. So this will have partially positive charge and here partially negative, and then there will be positive negative ketone, and then ultimately convert into the enol form convert into ketone. Yes or no? Keto enol form tautomerization. This is not given in the NCERT. It just mentioned it is given in 11th class. But Samarth, you got both question from ozonolysis as well as from this hydration of alkyne in your test,
Yes, sir.
correct?
Mm.
Hmm. Next reaction are popular and you can make those reactions very easy. So here we did 4 reactions. In the first two reaction, alcohol converted to aldehyde or ketone by oxidation. So in one case, oxidizing agent is PCC. Second case, copper with high temperature and alcohol vapor. Third, ozonolysis, ozone and zinc dust. And fourth, hydration of alkyne. Here we get both ketone as well as aldehyde. But if you need any specific, especially aldehyde, then we use next reaction preparation of aldehyde. This is easy, but still very popular for your board exam. Not only board, everywhere you need this. And you know all naming reaction are important. So, Chinmay, what is the first reaction?
Sir, Rosenmund reduction.
Very good. So, what happened in case of Rosenmund reduction?
Yeah, sir. So we take acid chlorides and then they are
Uh,
reduced in the presence of hydrogen or in the
hmm,
presence of palladium catalyst
correct.
and then barium sulfate to give aldehydes.
So, we have benzene ring, and this is acid halide. When you do reduction, addition of hydrogen is reduction in the presence of palladium sulfuric acid, or sorry, barium sulfate, not sulfuric acid. So, what will be the product, Samarth? HCl will come out. Out of these two hydrogen, one will bring chlorine out and hydrogen will be add. Yes or no? Same
Yes, sir.
as positive as negative, as positive will take away the chlorine and then aldehyde will be remaining. Correct?
Yes, sir.
And this reagent name is acyl chloride as well, because acid chloride you already know. Acyl you will feel ki, okay something else, but acyl is this. C double bond O is known as acyl. Samarth, what is the second reaction?
Sir, oxidation.
Oxidation. What happened in case of oxidation?
Sir, we use another stronger oxidizing agent to get carboxylic acid from this
To
thing.
get carboxylic acid.
Yes, sir.
Like if you use strong oxidizing agent, definitely you will get the carboxylic acid. But here, because we are doing aldehyde preparation only, and this time we are doing it from nitrile or ester. Either you take nitrile or you take ester. Since what is the formula of nitrile?
RC triple bond N.
Yes, and what is isonitrile?
Isonitrile, I'm not sure.
Samarth isonitrile,
Sir, RNC.
RNC,
RN.
cyanide isocyanide, na?
Yeah, sir. Yeah, sir. Yeah.
So when we add stannous chloride in this SnCl2, what is the stable oxidation state, Samarth, for Sn? +4 or +2?
+4, sir. It's lower metal.
Are you sure +4 or +2?
+2, sir. Metal is lower.
Chinmay +2 or +4? This is group 14 element.
So I think +2 only because it's
+2, +4. Sn is from group 14 elements, so it can show both +2 and +4, but +4 is more stable. In lead Pb, +2 is more stable. Got it?
okay.
In Sn, +4 is more stable, but both can exist. In lead, mainly +2. It why I'm telling this story? Because here you have +2. This +2 will try to go into the +4. So what will be the product which is not shown in NCERT. SnCl4. Why? Because Sn is more stable in +4 compared to +2. Tell me, Chinmay. Is it given in NCERT?
No, sir, I don't.
And this help you to understand group 14 P block if they ask question कि if you have Sn in +2 and Sn in +4, which one is more stable? So you will say +4 is more stable. That is the reason why here it is converting from +2 to +4. Okay. Now two chlorine are added here. So it means two hydrogen will be available. What will be the use of these two hydrogen? One hydrogen added with carbon, another hydrogen added with nitrogen. Remember, what is the name of this compound? Like, what is the functional group in this compound? Imine. Very,
Mine.
very, very.
Yeah. Yeah.
Okay. So, nitrile you take as reactant with stannous chloride, and then the stannous chloride will convert it to SnCl4, and imine will be formed. Double bond with the nitrogen will be imine. Chinmay, if you add H2O in this, what will happen?
Sir, we'll get aldehyde and
How?
ammonium chloride. So the
Aldehyde and
hydrolysis.
yes, aldehyde and
Ammonium chloride.
no ammonia. How? It will break down to O to 2 negative and 2 as positive like this. Got it? If you
Oh,
break this bond, this will be 2 positive, this will be 2 negative. Understood?
yes, sir.
Two bond are broken and nitrogen is more electronegative. That's why it will be like 2 negative carbon nitrogen. And because nitrogen is 2 negative, that's why carbon is 2 positive. If it look like this, what will happen? It will react with the water. Two hydrogen will bind with the carbon, sorry, nitrogen and form ammonia because ammonia is a stable gas. And this is uh, Samarth NEET, sorry, what I'm saying. JEE can ask question like this. In case of Stephen's reaction, when imine react, one of the byproduct along with the aldehyde will be. Got it? Or like what is the gas that release in Stephen's reaction when you prepare aldehyde?
Yeah.
Got it? Both of you.
Yes, sir.
So what you have to understand Stephen's reaction, nitrile form imine and then aldehyde. Okay, so you will remember aldehyde. Why? Because in aldehyde preparation you have four more important reactions. First Rosenmund, second Stephens, third Étard, and fourth Gatterman coach. Right? If you know these four names are given in the aldehyde preparation, it means product is aldehyde. Correct? But
Yeah.
Yeah.
I have seen this one question and then even in the beginning you will feel ki, oh, I forgot this. Example, if you take RCN, you will even remember Stephen's reaction, but other than that, you can use Dibal here. And if you use Dibal here, it will lead to the formation of the only aldehyde, not alcohol. What is this Dibal Chinmay?
Sir, it is diisobutyl aluminum
Yes,
hydride.
correct. Diisobutyl
Aluminum.
Al aluminum H hydride, B butyl, and D I means diiso. Okay. Samarth,
Yes.
if I take this CH3, CH double bond CH, then C triple bond N, and I use Dibal H, what will be the product?
Sir, double bond is preserved, sir. Only aldehyde.
Exactly. That is the reason why this reaction given in NCERT. Ki double bond is not affected by Dibalex. No doubt Dibalex is a reducing agent, correct?
Yes, sir.
But in this case, double bond is preserved. And I have seen this question, and even in the beginning, when I just started teaching, I used to forget this part. If you have any R, C double bond O, C2H5, Chinmay, what will be the product? And I have seen this question, ki RCHO, what will be the product? Sorry, what will be the reagent?
I'm not sure, sir. Don't know.
Dbal H.
Because double.
Yes. And again, it is reduction. Dbal H is a reducing agent. So in all the reaction, reduction is happening. And how it is reduction? Because you are removing one oxygen here, correct? The mole of oxygen is reduction. Addition of hydrogen is also reduction. Okay, remember, sometime examiner ask direct this reaction. You will never forget Stephen's reaction. You will never forget Stephen's reaction, and nitrile or cyanide is used there. But you might forget this ester. Okay, then after that, uh, sometime you use toluene as the reagent, and you make aldehyde from the hydrocarbon, mostly toluene. And you have three famous reactions. First is the Étard reaction. In graduation, you have very long Étard reaction, but here they give direct. Some teacher you will see ki they are very emotional when it comes to the Étard reaction. Have you seen in class, your class teacher, ki they are explaining you the mechanism of Étard reaction?
Yeah, sir.
Saman?
Yeah, sir.
You know why? Because Étard reaction mechanism is really important in graduation and post graduation. So they have this intention of reading this Étard reaction with the mechanism. For 10 marks, it is usually asked. But for us, only reaction is more than sufficient. No need to understand full mechanism. But you have to understand one thing. Ki usually, whenever you have like here hydrocarbon, you are taking toluene. So with strong oxidizing agent, it will try to convert into carboxylic acid. With strong oxidizing agent, strong oxidizing agent. Chinmay, can we say if we have to stop this at aldehyde level, so we have to use mild oxidizing agent,
Yeah.
correct?
Yeah.
If you use mild oxidizing agent, then you will form aldehyde. Strong oxidizing agent, carboxylic acid. Samarth, if you use molybdenum oxide with the hydrocarbon, what will be the product?
Sir, one is weak oxidation, other one is aromatization.
In case of normal hydrocarbon, alkane,
Sir, it should stop at alcohol.
it will form aldehyde, hydrocarbon, control oxidation. Do you remember?
Yes, sir. Yes, sir. The confusion is there among copper and.
If you take this acetate part, then carboxylic acid will form. But if you take example CH3CH3 with molybdenum oxide, then you will form aldehyde. KMnO4 or acetate form CH3CO twice like this, then carboxylic acid will form. This is control oxidation. Why do we call it control oxidation? Because we are controlling oxidation process. If you do too much oxidation, then carboxylic acid will form. Any doubts in me?
No, sir.
So here in Étard reaction, this is Étard reaction. You take toluene, then you use chromyl chloride. Remember this word. You will use same chapter, same word in D and F block. Correct? D and F block. Chromyl chloride. Chromyl chloride. Because in your objective question, most of time they don't give you formula. They give directly chromyl chloride. If you use chromyl chloride with the toluene, what will be the product? What will be the intermediate summary? And why we are using CS2? Tell me why we are using CS2 here. Why
So
we use
CS2
CS2 in general?
non-polar solvent, sir.
Yes. So guys, remember CS2 is a non-polar solvent. It reduces activity of the reactant because, as we know, if this chromyl chloride react too much, then probably carboxylic acid can form. Okay. To reduce the activity, what will you do? CS2. What will happen here? In the easiest language, one oxygen go forward, one oxygen go backward. Okay, and both of them will attach to the carbon. Carbon. See, O, Cr, Cl2OH. O, Cr, Cl2OH. Like this. Okay, so this is chromium complex. Complex that contain chromium. Correct? If you take H2O, simple water is added in the form of the acid. What will happen? Aldehyde. So this reaction is very, very, very popular. Remember this name, Étard reaction. What is special in this? You take toluene in presence of chromyl chloride. First chromium complex will form and ultimately aldehyde. Usually nobody asks you this complex, middle complex, but they can ask you in JEE. They can definitely ask you why CS2 is used to reduce the activity. Got it, guys? Any doubt?
No.
No.
Samarth, one more question for you because we did hydrocarbon together. What was the question? Huh. You want to make this um, toluene from heptane. What will you use?
Sir, V2O4 MO2O3 under temperature.
Vanadium oxide or molybdenum oxide or chromium oxide, right?
Yes.
At very high temperature, this process is known as
Aromatization.
aromatization. Exactly. And we can make it from the heptane, right?
Yes, sir.
Yeah. So this is given in the hydrocarbon again. So Chinmay, if you have same toluene, but you don't want to use chromyl chloride, your intention ki no sir, I will use something else. I will use acid anhydride. This is acid anhydride. Okay. So if you do this and you keep low temperature 0 degrees Celsius to 10 degrees Celsius. Why? Too much high temperature will increase the reactivity. Correct?
Yes.
If you increase temperature, reactivity is more. Chemical kinetics say that if you increase 10 degrees Celsius temperature, chinme, rate of reaction, rate constant will become chinme. If you increase the temperature by 10 degrees Celsius in Arrhenius equation, rate constant will increase by
Oh, sir, what, sir?
Samarth
Twice, I think.
twice. By every increase with 10 degrees Celsius, rate constant will become double. That's the reason why we have low temperature here. And trust me, these special things, CS2, this low temperature, same thing in diazonium salt. Do you remember? In diazonium salt, we have 0 to 5 degrees Celsius temperature, very low. You know, sometime when you write in Kelvin, na, you miss the that feel. Okay, it's very low temperature. But when you write in degrees Celsius, because in everyday life we see more like degrees Celsius, so you can feel it. Oh, 0 degrees Celsius is very low. Correct.
Yeah.
So what will happen in this case? Exactly in the same way how you did in the Étard reaction. This oxygen will added in the beginning like O, CO, CS3, O, CO, CS3. And in the end, if you heat it in presence of water and acid, what will happen? Benzaldehyde will form. So if you see here, reactant and product is exactly same. What is the difference? The reagent. Here you are using acid anhydride and chromic acid. By the way, this is chromic acid. Chromic acid. But here you use chromyl chloride. In both situations, product is exactly same. Condition is different. Got it? Okay. Tell me, Samarth, what is the name of this compound?
Chromium complex. This is
This
not
is,
chromium.
you don't have chromium in this.
This is Sir, in NCERT, benzylidene diacetate.
But why we call it benzylidene diacetate?
Two acetate groups are there.
Hmm.
Ylene is used for CH, like methylene, similar to it. So like one methane with like two valencies.
You are confused, right?
Yeah.
See,
And
acetate part is easy. C double bond O, acetate ester, and two carbon, so acid. Two time di. Two time di. Acid means two carbon. Eight means ester bond. You have benzyl group if it contains CH2. But if you remove one hydrogen, it will become benzylidene. Okay, it could be CH double bond or it could be anything else. So CH2, if you had here, it would have been benzyl only. Here benzylidene, like amine NH2. If you remove one hydrogen and add double bond, imine I, right? Got it?
mm,
Exactly in the same way. Any doubt?
No, sir.
mm,
If you understood this, third reaction is also exactly same. That's why during the summary, for us it will be easy to do the same thing. Ki you have same reactant and product. Toluene is making benzaldehyde, but method is same. If you take chlorine and heat it, so what will happen? Chlorination will happen. Substitution of alkane. Do you remember, Samarth? First reaction of alkane,
Yes, yes.
substitution, chlorination.
Yeah.
Chinmay, this is given in the haloalkane second reaction. First from alcohol, second from the alkane.
Yeah, sir. Yeah.
So if you take water and again you heat it. Now just imagine when we said here, heat it in presence of water. At high temperature, same thing here, 100 degrees Celsius, heat it. So what will happen? F- Let me tell you here, first this Cl will be replaced by OH each time. It will be like CH, OH, correct? And 2HCl will come out.
Yeah.
Then this H2O will also come out. What will be the product? Make sense?
Well,
Yeah, sir.
yes.
Hmm. Done.
In
So
agreement, you know.
exactly. This is for understanding part ki how we write this table product and all. So what you did in a quick summary of this from the hydrocarbon. If you have toluene, there are three methods. Whether use chromyl chloride, product will be same. Second, chromic acid in presence of acid anhydride, correct? At very low temperature, 0 to 10 degrees Celsius. And third, in presence of chlorine, you heat it. In all the three situations, product will be same. It's your choice which method you want to use. Whether you want to use Étard or you want to use chromic acid or you want to use side chain chlorination. Got it?
Yeah.
Last and still very famous Gatterman quotes. This is like easiest reaction you will never forget. Chinmay, what is Gatterman reaction?
Sir, it is a method of preparation of what is that, sir, in the haloalkane software?
Right, very good. It is in haloalkane.
It Sir, it's same as Sandmeyer's reaction, but we
Very good.
replace this thing by what is that, sir? Zinc? No,
No,
copper. This thing, sir. Copper dust.
correct. Copper powder.
Copper powder. Yeah.
And in case of Sandomir, we use copper cuprous chloride.
That's
But
correct.
in Gatterman, everything is exactly same as Sandomir, but copper powder. That's all. So here Gatterman quotes, you are making aldehyde, you know this reaction, carbon monoxide and HCl is important. And with this, all the preparation of aldehyde is done. Okay. Summary is like too easy to do. You want to make aldehyde. First reaction is Rosenmund reduction. When you take Rosenmund reduction, you do it from acid halide. Correct. Second, Stephen's reaction. You make it from the nitrile or cyanide. Or third, you use the BALH. You can make it from the ester also. Correct. And I will write here RCHO. Fourth, Étard reaction, Étard reaction, and you will use chromic chloride. Correct. You can use chromic acid and acid anhydride, or you can use chlorination in all the three reactions. Reactant will be this. And last, COHCl Gatterman coach, KC, Gatterman coach from the benzene ring. Tell me. Preparation is done, guys. And trust me, Chinmay, from this only you will get minimum two reaction in your exam. And in your competitive exam, you will get one question only from this. I'm talking about competitive exam mains.
Yeah.
Okay. One fixed question in CT, one question in mains, and two question in the two name reaction in the this board.
Yeah.
Next is ketone formation. Ketone formation is way easier because there is no name reaction as such, and that's why ketone formation is comparatively easy compared to aldehyde. Because aldehyde reaction they always ask ketone, there is no special reaction as such. That is the thing. Ketone preparation. There is no separate preparation. You can prepare like when you combinedly formaldehyde and ketone. Samarth, what were the reaction for the aldehyde and ketone formation together?
Uh, sir, Grignard with cadmium chloride.
No, that is given here. I'm asking what we did together, aldehyde and ketone.
I didn't understand, sir.
Like we already did mixture of aldehyde and ketone. What were the different method?
Sir, oxidation,
Oxidation,
dehydration,
dehydration,
hydrogenation, sir, with copper.
dehydrogenation, hmm.
Uh, sir, then this thing, ozonolysis.
Ozonolysis, one more, one more.
One more in
Wow, very famous this reaction is. Mercury something,
sir, hydration of
hydration of
alkynes, sir.
exactly.
Sir,
So
but that
hydration
gives
of
keto form, right? That's what my confusion.
ketone form. So this is what that is why I'm saying ki you can write here also, correct?
Oh, okay. Yes.
If you have alkyne and you add mercury sulfate and H2SO4, then you can write reaction here only because ketoenol form is more stable, so keto form will form because of the tautomerization. Chinmay, any doubt?
No, sir.
Here, what is happening if you take Grignard reagent using cadmium chloride? So, uh, Mg will be added with the chlorine because more stable, and here you will have cadmium dihalide. When this react with the acid halide, then ketone will form, only ketone. Second, from the nitrile, but again in the same way, Grignard reagent. How? Example, if you have RC triple bond N and it react with the RMGX, always write normal form in dry ether. So what will happen? Here you will have RC double bond and MGX, and here it will be R dash. And in case of water, it will be RC double bond O R dash. Correct? So from nitrile, you can make this. Chinmay, if you have same nitrile, but instead of RMGX, you are adding SnCl2. What will be the name of reaction and what will be the product?
Sir, if we add
SnCl2,
the Stefan's reduction also.
Stephan reduction. Okay, and what will be the product?
Uh,
Hmm. Aldehyde formation, right? Stephan we use in the aldehyde formation.
sir, you're asking for that only, sir.
Yeah. So
Yeah,
here what happened if you see R
yes,
R dash
yeah.
and ammonia can be removed. If ammonia can be removed, you can add oxygen. In Friedel-Crafts acylation, if you take benzene ring and if you do RC double bond OCl, Samarth, what should I add here? What should be the reagent?
Anhydrous AlCl.
Anhydrous
AlCl.
AlCl3. Why?
So it acts as a Lewis acid because aluminum has deficiency of electron.
Hmm.
It takes the
Because
chlorine
it can convert into this form and
AlCl.
this will form carbocation, correct?
Yes, sir.
And
So,
this
yeah,
and this
acid.
electrophilic substitution reaction can attack here. Hydrocarbon again, right?
Yes, sir.
Electrophilic substitution reaction. And what will be the product? COR ketone. Done. And route. Okay. So this is about all the formation. We did only three method here. One from the acid halide using cadmium chloride. Second from the cyanide or nitride using Grignard reagent. And third, Friedel-Crafts acylation, normal reaction from hydrocarbon. Physical property, no need to mention much because boiling point you already know. Chinmay, how boiling point will change in any compound? If we increase carbon, boiling point will
Increase.
increase. If we increase branching, what will be the impact on the boiling point? Decrease, right? Surface area. But you will see if you take HCHO, this is gas. If you take CH3CHO, this is volatile liquid. It means it can easily convert into gas. Correct? And other part will be either solid and liquid. But here you will have special bonding known as dipole-dipole interaction. Which interaction? Dipole-dipole interaction. And what is the impact, Samarth, of this dipole-dipole interaction?
So intermolecular
Samarth.
forces of attack.
Yeah, so intermolecular force will be strong. What will be the impact of this? Chinmay?
So it will be difficult
It will be difficult.
uh, to separate each other. So like more energy is required to.
Difficult to separate, more energy is required, and boiling point will increase. If any other molecule like ether, hydrocarbon have same mass, and then you have aldehyde ketone, then aldehyde ketone will have more boiling. Why? Because of the dipole-dipole interaction that can be asked in JEE. It will be never asked directly. They will give in one of the options. right or wrong statement. Got it?
Okay.
Right. So this is really, really important. Example, if you take this butane CH3, CH2, CH2, CH3, here molar mass will be 12 for the 48, 48, and 336 and 10. Here 58 is the molar mass, correct? And now you take CH3, CH2, and CHO. What is the molar mass in this case? 36 and 642 and 16, again 58. Both have exactly same molar mass, 58, 58. Cinema, which will have more boiling point?
The first one. Second one.
Aldehyde. Why?
Aldehyde.
Dipole interaction. Now you understood what was the meaning of this statement, guys, both of
Yes,
you.
yes, sir. Yeah.
Even mass of this uh, aldehyde is same as hydrocarbon, but still its boiling point is more. Why? Because of the dipole-dipole interaction. Got it? And if you take this CH3, C double bond O, CH3. If you take here, molar mass is 58. Summer. Will it be more than aldehyde or less than aldehyde or equal to aldehyde?
Uh,
How?
a little confusion is there. I think more than aldehydes.
Why?
Uh, the polarity between carbon and oxygen.
It is same. Here we are talking about boiling point. More because of the symmetry. Here you have more symmetry, so more boiling point, melting point.
So
Correct?
it's only for melting point, right? Symmetry.
No, symmetry matter in both, but melting point will be more impacted. Like you can probably see the difference, a lot of difference in case of melting point because of the pattern.
Okay.
But even it will be slightly difficult to boil. Difference is not much, but it will be slightly difficult to boil because of better packaging. Correct? No doubt. Your point key packaging affect melting point more than boiling point. That is correct. Chinmay, if you think about solubility, are these carbonyl compound more soluble in water or not? Solubility. Last
Lower
point.
numbers of aldehydes, methanol and ethanol and propanol.
Yeah. One thing I forgot to mention. When it comes to the boiling point, na, boiling point of aldehyde ketone is less than alcohol. Why?
Because absence of intermolecular hydrogen.
Yes. Boiling point less than alcohol. Because in alcohol you have proper hydrogen bonding. In alcohol you have proper hydrogen bonding. Here hydrogen bonding is absent due to absence of hydrogen bonding. Yes, Chinmay, you were telling me about the solubility. What will be the impact of the solubility of carbonyl group?
The lower members of aldehydes and ketones, they are soluble in water, and after that, the higher members are insoluble.
Exactly like the in general, when you increase carbon, then they will be more non-polar. Non-polar nature will increase, or you can say polar nature will decrease. And if this decrease, then what will happen? Solubility will decrease. This is a general trend, correct?
Yes.
But lower mem like If you compare to the hydrocarbon, are they more soluble or less soluble?
I'm not sure.
Samarth,
More soluble, I think.
more soluble than hydrocarbon. Why?
Sir, apolarity.
One reason is polarity, but one more reason is it can easily form hydrogen bond with water, right? Example, if you have H2O, then this can form hydrogen bond, right?
Yeah.
Form hydrogen bond in water. That's why it is more polar. Got it?
Yes, sir.
One more thing that usually we miss because this is more like theoretical parts, but still can be asked in exam. If you take lower member, lower aldehyde, these lower aldehyde have very bad smell, sharp pungent smell. Though it is a simple point, sharp pungent smell in the lower aldehyde. And if you increase carbon, then this pungent smell will reduce. And if pungent smell reduce, a good smell or fragrance will increase. That's why you will see कि when we use perfume na or this fragrant material, what will happen? They will have more number of carbon. Got it? So lower aldehyde, very bad smell. And as you increase number of carbons, smell will be good. Got it?
Yes.
And preparation part overall is done. Now we are left with the chemical property. As I mentioned, in two more class, we'll finish this. But chapter is incomplete
Carboxylic.
Carboxyl.
without questions. Chapter is always incomplete without questions. So let's see what kind of question are they asking. JEE Mains previous year, chapter wise chemistry, aldehyde ketone carboxylic acid. Mhm. 2 mole of hydrogen and oxidation came under for note this. Clemens Jackson, not this. PCl5, not this. Spelling test we didn't do. Yes. Cinema. What is the result of first step? Forget about the second step. First step, when you use CrO2, Cl2 and CS2.
Chromium complex.
Huh. So, yes, Chinmay.
Chromium complex. Étard
If
group.
you are using chromium chloride in CS2 and here you have toluene, if toluene react with chromyl chloride, what will be the product?
Chromium complex. Étard group.
Carb benzaldehyde.
Yeah, finally it's benzaldehyde.
Okay, so at least as of now, you know when toluene react with the chromium chloride in CS2, product is benzaldehyde. Okay, this part we will do in nucleophilic addition reaction. Okay, so we'll do in the next class this part, but based on this reaction, at least you can do this. This is done tolerance reagent test. Formaldehyde. Hydration is faster in which reaction? This is not you have right now. Yes, you can do this. Yes. Aman has been asked to synthesize the molecule. He thought of preparing molecule using aldol condensation. He found a few cyclic alkene in his laboratory. He thought of performing ozonolysis. I'm looking for this part only, ozonolysis reaction of alkene to produce dicarbonyl compound and then aldol. Aldol we can't do now, but he thought he will take one compound, do an uh, ozonolysis and produce alkene. What should be the molecule? I will show you options. Why am okay? You can see option also, and you tell me why. Is this visible, guys? Ozonolysis. Alkene react with ozone, then further zinc, and one oxygen will be added. Correct? Can be any doubt in this?
No, sir.
So answer is D. If you use, if you break down this, what will happen? This bond will be broken. Correct, Samarth?
Yes, sir. One ketone and one aldehyde will come
One ketone and one aldehyde
on the same carbon, on the same
on the same.
compound.
Huh. Answer is in this case, this bond will never broken. No, this bond will be broken. Why? Because the ring itself act like double bond, right? Samarth, a ring itself act like double bond. Chinmay, any doubt? A ring itself act like double bond. And if you break the ring, what will happen? You will add one oxygen here, you will add one oxygen here. Yes or no, Samarth?
Yes, sir. So, but won't that form diene?
What?
Won't that form two double bonds at same carbon?
No, we are breaking the bond. We are not making. Correct? We are
Yes, sir.
breaking the bond.
Yeah.
So what is happening? Number of carbon will be same. See how many carbon are here. In the reactant, there are 7 carbon here. 1, 2, 3, 4, 5, 6. And here it will be oxygen. So, yeah. Now check. What is number of carbons, correct? There will be 7, and here it is 7. This green dot, 1, 2, 3, 4, 5. This carbon 6, and this carbon 7. 1, 2, 3, 4, 5, 6, 7. Total 7 carbon. Remember, when you have a ring itself is a double bond. Chinmay, what is the formula of this uh, ring? Number of carbon and hydrogen. C3H. Chinmay, C3H.
Uh,
6.
yeah,
2 hydrogen on each carbon.
yeah.
If you take CH3, CH2, this is again alkene. This formula is C3H6. Both have exactly same formula. Why? Because alkene are almost like cyclic compound, single cyclic compound, right? Samarth, any doubt?
No, sir.
So same thing here. If you have a ring, then in ozonolysis you will break the ring, not double bond. Got it? So one oxygen is added here, another oxygen added, other number of carbon will be same. This part you should know. Right? Other part will do later. The reactivity of nucleophilic. These are so many reactions. Yes, Chinmay, you will tell me all this reaction. And now see, guys, even Jay asked this kind of question. Chinmay, first question answer.
Stephen's reduction.
Stephen's reduction. Second, Samarth. Samarth second.
Sir, Rosenmund reduction. Sorry,
Rosenmund reaction. Chinmay third reaction.
So Étard.
Étard. And fourth, Samarth.
sir, only one it left. Get away.
Yeah. But this kind of question in JEE is rare. They can ask. And same kind of question is common in JEE, CET as well as board. This kind of simple question because they directly given the exam. It is just for quick revision, nothing else. CO2, COH. Individually, you will have so many questions from all these reactions. Hydroform, Canizero, aldol, tollens. You just imagine it is 50% of the first chapter question is test. Hydroform test, Canizero, aldol, Clemenson reduction, Wolff-Kishner reduction, compound, Fort Kamenov. I'll do 1-2 question. Yes. Samarth, is this hydration of alkene?
Sir, it's zinc Hg is there, so it's Clemenson's.
It is Clemenson reduction. So that is a different reaction. Because sometimes people when see mercury, they try to attack, oh, it could be hydration of alkyne. When Elaine undergoes self, you have so many questions from other part. So, Chinmay, first reaction.
For the first reaction, aldehyde. You get aldehyde.
Aldehyde.
Uh, I didn't.
You are adding water in this.
Oh, it's
We are not using SNCl2 in this or our MGX.
oh, it's ketone, sir. Sorry. Yeah, white cut. Yeah.
Amide. How? This H2O will break down into H positive, OH negative. This OH negative again further break down into O2 negative and H positive. So ultimately you have two H positive and O2 negative. Same here. If you break two bond here, so oxygen added here, hydrogen added here. Any doubt? Simple addition of water, hydrolysis.
Yes.
Samarth, B.
Sir, carboxylic acid.
Carboxylic acid. R will attack on C, O, and then H will be added in the last reaction. And Mg, X, and OH, right?
Yes, sir.
Chilme, third reaction.
Third,
Aldehyde, Stephen's reaction. S- uh, Stephen's reaction. Samarth, B.
Sir, aldehyde we get again, PCC.
Aldehyde because mild oxidizing agent. Mild oxidizing agent. If you have strong oxidizing agent, then carboxylic
Carboxylic.
acid.
Yes.
Okay. So that now you are seeing ki you will get this kind of question, but there are more questions from aldol condensation, Canny zero, Fehling solution test, Tollens reagent test, hydroform test, nucleophilic addition reaction. From there you get lot of question. Majority question of this chapter you get from there. That's why next class will be extremely important. And Chinmay, I understand you like you read throughout the day, so both of you get tired. So take proper rest before the class. If you are tired, just take half an hour nap so you feel better. Okay. So that's enough for today's class. We covered more than like around one third portion of the chapter. Okay. So tomorrow we'll try to finish this aldehyde and ketone, but let's hope for the best. I'm not sure to be honest. Okay, guys. Good night.